I'm going to apologize in advance for what is probably going to be a little bit of a long video. The law of sines is a very simple looking law. You'll see it the way the textbook writes it. You also see it as a reciprocal. Sometimes they kind of flip those fractions. Either way is totally fine. But even though it's a very simple formula, you have to kind of check it a couple of different ways. And it will relate back to those old two-column proofs some of you might have done when you were in geometry, where you were proving two triangles to be congruent. Now, there was a couple of different ways to prove triangles congruent. There was angle, side, angle, 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 side. Usually we write it the other direction. I don't know why they wrote it like that. And there was also side, 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 and angle, side, side, angle, side. That's not listed on there. What wasn't a way to show how two triangles are congruent was side, side, angle, purposely written backwards, right? I did that when I had to teach high school too. You can't write it the other way. This is going to be our problem child here. We can use law of sines with this, but we're going to have to check it, where if I'm talking about angle, angle, side, or angle, side, angle, we don't really need to check it. It's going to work. This is my law of sines. Sine of A, angle A, opens up to angle, side A at the same rate, at the same way that sine B would open up to sine B and sine C to C. Like I said, sometimes these guys are flipped upside down like this. It doesn't really matter which way you do this. And you can pick any two at a time, right? You can't solve over two equal signs, but you can say, all right, I'm going to say sine A over A to sine C over C, or sine B over B to sine C over C. It does not need to be in any particular order, and it could be upside down. So pretty simple looking formula, but it can get a little crazy. If I'm proving something through angle, side, angle, let's draw this out. I'm going to draw this as A, B, and C. I got angle A is 20 degrees. Angle B is 25. And side C, so across from C is 4. And that's how you know it's angle, side, angle. You want to be able to think of these things as stones, and you're jumping from one to the next. So it says go to angle, start on an angle, jump to the side that's right next to it, and then jump on the next angle right after that. So I got, let me get a highlighter, angle, side, angle. All right, so you got like a little side sandwich there, right? If you're given two angles, life is pretty good, because it's very easy to find the third angle, because we know that these have to add up to 180 degrees. So I know right away this has to be 135 degrees. That's good news, because now you can scale your triangle bigger or smaller, but those angles are locked. So the way that this triangle changes is not, it has to change, I'm going to say evenly, at the same way all the different sides. So it locks in the shape. Think of it as, you know, when you highlight a picture, right? And it's like this big, and then you can grab this angle and you could draw it out like this big, but everything grows at the same rate. That's what's going on with these triangles. So they're similar triangles. So now we want to find the rest of this, because the storyline is always just, hey, solve me. So notice this is not a right triangle, and you can't just be dropping in altitudes wherever you want. Sometimes it's easy if you have something that's like an isosceles or an equilateral, but if not, then it's going to be more work to do it like that than to just use law of sines. So I have angle C, and I know it opens up to side length 4, and so that's going to be my starter. So I'm going to say the sine of 135 opens up to a 4. Sine of a 20, that opens up at how, right? Because these rates of change have to be the same, because those angles are locked. So I'm going to go down this column first. They leave the sine of 20 as they multiply. You could divide it out and write out a bunch of decimal points or not. But what's going on here is you're going to cross multiply. So I'm going to come out to the side here and get 4 times the sine of 20 is equal to A times the sine of 135, and then you could divide off the sine of 135 from both sides, and that's how they get to that mess right there. Plug this in your calculator, make sure that you have all your parentheses where they need to be. I like to do it in steps because you see I have an old version of the calculator. It's hard to tell where some things land. And you get that side A is a 1.93. Great, one more side. Can't use Pythagorean theorem because it's not a right triangle. And also, you want to go back to side C. Don't keep side A running now. Don't say, oh, sine of 135 opens up to a 1.93 because you have this rounding error in here. So it's going to be more accurate if I use side C again because these are nice numbers. Same thing as before, sine of B, which is a 25. What is that going to open up at? And you do the same exact steps. Sometimes it's just type in and plug and chug. Sometimes it's a cross multiply and divide. And sometimes you have to do an inverse sine, right, if I'm looking for an angle. And now my lovely little triangle is solved and all of this is filled out. I forget who was a 1.93, and he was a number I forget already. Don't get old. You can't remember anything that happens. So that's angle, side, angle. If you have two angles, you're happy. Side, side, angle. I don't have two angles, so I am not happy. That means I'm not entirely sure what this triangle looks like. And when you have a no solution, you're going to run into that pretty quickly because you're going to not be able to take the sine or find the inverse sine of the ratio, right? It's just not going to be possible. If it's a one triangle or a two triangle, because those are my other two things, it may or may not be possible to have two, but you have to check it. I'm going to skip over this just a little bit so that you can see this. What happens with a no is that when you go to find this, it's too short or too long, or more like this side is too long, and you can't close it. If you have two triangles, what happens is you're looking at something that maybe looks like this, where let's say I have a, let's make this a 120. Let's make this a 30 and a, is it 30 and a 30? Oh, 30 and a 30. No good. Let's say 40 and 20. So maybe it's this, but maybe it's actually that it's like this, and there's a like a 160 here, and like a 10 and a 10 or something like that, right? So you're not really sure where the swing is going to open. Think about it as a door, right? So my door could be closed here, swing in, or it can swing out. If anybody's ever worked in a restaurant and kind of have those double swing doors, it could go anywhere. It's kind of like that. Let's look at the no solution first. I got angle C being 50, side C opens up to a 1, so you got to have a buddy, right? Big C and little c, big A and little a, something like that to do law of sines. A, B, C, doesn't matter what your triangles look like. Here's my buddy. Side A opens up to a 2, so let's start with finding out what angle A is. Sine of 50 opens to a 1. So the sine of A, that's got to open up to a 2. And that's not a problem. And I get that the sine A, right, times 1 is 2 times sine of 50. Well, sine of 50 times 2 is a 1.53. That is a problem. You cannot have a sine value that's bigger than a 1 or smaller than a -1 because the domain of sine is from -1 to +1. Same thing with cos. So if you go to type in like inverse sine of 1.53 in the calculator, it's going to go error, right? Dimension mismatch or something like that. And that means you're done. You can't make that triangle. And so we have our door swinging, but the door actually never closes, so you just want to take that off. Let's go to look at one that gives us two triangles, which I guess is not in the PowerPoint, but is super important. So we're going to go to the worksheets. So number 8 on the worksheet is A equal to 2, B equal to 3, angle A is equal to 20. And you can't really tell by looking at them exactly what's going to happen. You could draw it out and see if it's going to be good news or bad news, but we know it's bad news, right? I only got one angle. And anytime I only have one angle, that makes me a little sad. So I maybe have no triangle like we saw before. Maybe I just have one. That does happen. Or maybe I have two. Now I can tell you on your midterm and your final, I promise you I will not ask you a no triangle because I will not make you go through the work to find nothing. Right? So there's going to be one that's one triangle and one that's two triangles. Now by looking at it, you know that something might happen that it's one or two or none, but you don't know which. You just have to kind of start. So I'm going to start and say sine of 20. That equals to a 2, so I'm going to go to B sine B. That opens up to a 3. So 3 sine of 20 is equal to 2 times sine of B. Divide off this 2, I got a 3/2 sine of 20. That's equal to sine of B. Calculator. Let's see what we have here. 1.5 times sine of 20 is that. That's the sine of B, so I need to say what angle has that sine? What angle has that sine? I'm going to say 30.9 because I don't know what they asked for. I'm at 30.9. Okay? Now maybe that's what B is. Maybe that's what's going on here. Maybe this is a 30.9. And if that's a 30.9, this has to be a 139.1. But maybe it's not a cute little acute triangle. Well, obtuse because of this, but you know, kind of normal looking. Maybe it's like super squished in like this, right? Because that could happen, and when you get a two triangle situation, it tends to look a little weird. So that's B1. B2 might be 180 because of a supplementary line, supplementary angles, minus 30.9. One angle because it's a supplementary angles, not because of the triangle. And maybe it's 149.1. All right, so the question is, I know A is a 20. If B is a 149.1, does that still leave me enough room to make a third angle? Yep, but not much. 10.9. And so now what I need to do is use the law of sines to find, well, what's C if it's 139, and what's C if it opens up to a 10 from a 10.9. All right, so sine of 20 opens up to a 2. A sine of a 139.1 opens up to something. So this is going to be C times sine of 20 equals 2 times sine of a 139.1, and I'll divide off sine of 20, and I get a 3.8-ish. 3.8-ish. Now I'm lazy. All right, math people tend to be lazy. If I do this again, you notice the only thing that changes is the sine of a 139 is now a 10.9, and I can say second enter twice, and then write this over like that so that I don't have to type it all in again. I guess it's kind of the same, right? Sine 20, and it's a 1.1. And so you got two possible triangles. One's going to be kind of like a normalish looking triangle, and one's going to not be a normalish looking triangle if you drew it out, but you have to check for both.